Hello and welcome to this video where we shall be looking at how to cast primitives from a large size to a small size. This is going to be a quick video to show you how we can do some casting. I guess there's a few ways to do this. We could do something like this is going to error, but we could do, if we have an integer .parse int 3, we could have something like this where we're just parsing the integer. So what happens basically here is a method in the integer class, which is this class here, integer, it basically knows how to parse a string into an int to represent it as an int, because here we're passing a string and it's going to represent 3 as an integer. Another way to kind of look around this is if we have, say, long y equals 42, int x equals y. This won't compile. Reason for this is basically we're trying to shove a long into an int, and long is bigger than an int, and the compiler, obviously knows this. So we can't be sure that, how big long is at this particular point. So to force the compiler basically to jam y into x, we just do cast int y, and this works. So x is now equal to y, which is 42, but putting the cast on basically tells, the compiler to take the value of y, chop it down to an integer of respectable size, and set x equal to whatever is left after it's been chopped down. So if the value of y, which is here 42, was bigger than the maximum value of x, then what's left will be very strange, but it should be calculable as a number. So let's try it. So we'll do 4442. Let's just run this. Actually, let's not run this. This should come. Actually, yeah. Let me show you what happens. Let me show you. So let's do system.out.print line x and run this. So we get 42. But what happens when we put in this number? So we do have 4002, and this does exceed the limit of. It doesn't exceed the limit of x, but because x is an integer, but if we put this to short, and then we do this, turn that to short, we get -25534, which is thinking, how did we get that? Well, it's giving us a representation of what's left after what we've stored in short. So basically, not so much how to get around this, it's just that, y, which is a long number, exceeds the 16-bit limit of a short. So the point here is the compiler will let you do this, but it's obviously not good when we're getting this representation back as this number. It should, give us an indication instead of stuffing it all into x. What we could do is, let's keep running with this example. Let's do 3 x equals int f. So this should cast as 3 because we're getting whole number, obviously being an integer. There we are. So you can see this does actually work, and the compiler allows us to do it, but don't think this type of stuff works with stuff like booleans or things of that nature, because it will definitely not work. And if you want to kind of understand how this works, let's start looking into binary to complement and things of very similar topics to that, and that should hopefully help you understand. But basically what's just happening is you just stuff in a value, say from long, into an int, and it's just going to, into short. So if you're trying to stuff a value of long into short, it's only going to stuff in as much as it can, and then it'll return whatever else at the end. But yeah, that's pretty much how to cast primitives from a large size to a small size. Hopefully that was useful. It's just one of those things, it's kind of good to know just to see what happens. But yeah, okay, thanks for taking time to watch this video, and I shall see you in the next one.